Hey folks, thanks for everybody showing up on time. We'll be able to get underway in a few minutes here. How's Friday going for people? Some of you are at the end of your day.
There's no TGI emoji.
Some of us, it's end of the week.
Well, I'm not getting audio.
That's right. Can you hear us, Dan?
Somebody want to try talking again?
Testing, testing.
Okay, go through the laptop speakers. Those are normally more reliable, if tinny.
Can you hear us now?
Now I can.
Okay.
I thought, gee, everybody is so quiet today.
We were quiet anyways.
Well, the green circles are supposed to be a clue.
That when I saw Rave's blinking and Samuel's, then I thought, All right, we're coming up on almost 5 after here. See, Dan Williams has joined. I'll kind of get I think Dan normally gets things going, but to kind of kickstart, just go through the normals. Thanks for everybody for making time for this. This is our opportunity to speak at a little higher bandwidth than maybe we can over mail lists. This is a public open source forum, so don't say anything that you wouldn't be comfortable putting out to a public mail list. This is a recorded meeting. It's facilitated by the Linux Foundation and in part the Confidential Computing Consortium. Our technical community architect wanted me to mention that we've got resources for people looking for assistance with confidential computing, and you can reach out through the confidential computing channels to access anybody there. So we've got a Slack and mailing lists, and if people aren't familiar with those, I can drop links in the chat later. But we particularly for this topic, we try to make sure that everything relevant is reflected on the Linux Cocoa mail list, so that we're not affecting any normal kernel procedures.
Hey Dan, thanks for getting things started. The Chrome was crashing every time I tried to join Zoom this morning, so now Firefox is working, so I'm finally in. So thanks for getting things kicked off.
Sure thing.
Um, I was actually going to say that from the normal topics of device security, we have the RFC out there. The comments have been light, but we do have the act from Bjorn. And so at this point, we're really just waiting for that first mover to post the full stack with the PCI core integration done. So like, and I think part of that is also gated on some of the KVM prerequisites for different various architectures also moving upstream. So we're in a bit of a holding pattern. Not a holding pattern, but of a lull waiting for the next kind of posting on that stuff. So I'm glad that you propose that we also take the time to do the RTMR discussion this week. And so I'm okay to devote most of the time to talking about RTMR integration and formats. But if you have time at the end, we can talk about next steps on some of the device security things. But I'm okay to let you introduce. We also have some new people on the call this time. I noticed some familiar names. Did you already go through and give people a chance to do intros?
No, I didn't. Thanks for reminding that.
Okay, yeah. So this call started off as a way for cross-vendor collaboration on device security, but it's also a place to talk about any kind of cross-vendor kernel impact of confidential computing. And we'd like to give an opportunity for people that haven't joined the call in the past to have an opportunity. So go ahead and use the raise hand feature to make a queue, and I'll call off names as it happens, and we can go from there if people want to. So you go to the reactions tab and hit the raise hand button. Okay, so Samuel.
Hey, so I'm Samuel. I work for Revos, and this is the first time I'm joining this call. But I've been kind of participating to many of the discussion related to Trusted IO, and together with Ravi, who's on this call as well, we are driving the confidential computing specs for RISC-V, both at the CPU level, but also the IO specification. So those are ongoing specifications. And on that topic, then we are due to for a review of your pending patches for the latest one. So making sure that they kind of map the RISC-V specification that we're building. So hopefully I can have a look at those this week.
Sure. Yes, that's good. Yeah. Maybe at this point you can wait for the next posting. There's some feedback coming in, but yeah, it's ready. It's ready to take a look. And the good news is Bjorn kind of, my read of Bjorn acting at the RFC stage is basically like, hey, your integrations look okay. You guys figure out the details behind the integrations, but I'm not going to dig too deep into that side.
Yep.
Okay, thanks for that. Yusuf, I see you up next.
I'm Yusuf said I'm working from for the device assignment side of things for ARM confidential computer architecture. So I work along with Suzuki and work mostly along for the spec side of things. Yes, basically ramping up on the kernel side of things. I have been in this meeting like very early, probably a couple of months ago, and then I lost in touch. And today Suzuki reminded me that there's another meeting that's going on today, so I thought it might be interesting to listen in.
Yeah, we definitely have an interesting calendar that has gone back and forth. So if you missed a few, that's okay. Other people have trouble, but we have a stable schedule now. So welcome.
Okay, yeah, thank you. Thanks. That's all I have.
Suzuki.
Hi, I'm Suzuki. I work for ARM. I'm leading the Linux enablement for ARM CC architecture. So as Yusuf mentioned, we used to be in the calls in the earlier days using the poll, doodle polls, but we got busy with some of the upstream posting of the initial version. So, but hope to get back on this forum. Yeah, thank
Yeah, good hearing you again. Anna or Anna?
Hello. Yes, it's Anna, but
Okay,
anything will work.
okay.
So I work in Microsoft. I just joined the Azure Confidential Computing Group, and I'll be working on confidential GPU specifically. And before that, I was working at Intel on TDXIO with Ravi. So it's really nice to see a familiar face.
Yeah, you can't go far in this industry, yeah, without running into the same people. So that's really good. So welcome.
Same here, Anna. Good to see you.
Hey.
And then Ram.
Hey, this is Ram. And this is the first time I'm joining. I'm the architect for confidential computing in the IBM Cloud VPC. I have worked on in the Linux kernel in the past. Many here, I think, recognize me. I worked with James Bottomley as well. So yeah, I'm just watching out and seeing where I can contribute here and whatever technologies you guys build. So we'll have to bring it to our cloud as well. So
Okay.
I'm interested in that section.
Good deal. Satya.
Hey, this is Satya from Intel. This is first time joining here. Mainly work on like the TDX attestation and interested in the RTMR discussion today, so joined. Hi to everyone.
Welcome, Satya. And Carlos.
Yes, hello everyone. It's also my first time joining, and I hope I can join as much as possible in the future. Scheduling permits. I work for DLL Ocean, and before that I was working for AMD, and I have been interested in confidential computing for a while, and also see some familiar faces. So hello everyone.
Okay, good deal. So with no other people wanting to do introduction, Dan, do you want to kick off the RTMR topic?
Yeah, sure. So Samuel Ortiz has put together some material, and thanks to him for getting the first patch going. In the second, so there's two versions out there, and wanted to get some quick feedback on the direction of the third patch. I think there's a couple options there. I think this will be either very easy, yes, anything is good, or maybe we will find ourselves down a detailed path of formats. Hopefully the former more than the latter, but the whole point of this is to, you know, expose this quickly. So game for everything. And so I think Samuel's got some material that he's put together. So
Oh,
you're
okay,
welcome.
sure. Sorry, then I wasn't sure. Yeah, let me quickly share the visuals.
I mean, I guess I can give a little background. So a lot of the architectures supports measurement registers that are like the PCRs that are in TPMs, and some of these are available during runtime to the guest and afford some other use cases that go beyond boot. And so we want to get some creative use of those going forward. But first we got to make them accessible.
I even added a glossary at the end of this this slide deck. I know this computational computing stuff is so full of acronyms and different terminology. It's hard to make sense of different things. But yeah, thanks for setting the background down. A little bit, yeah. As you said, we sent the V2 of the RTMR Linux patch set. Which basically is allowing for user space to extend measurements and digest into RTMR. And one line on the cover letter on V2 is that the to-do list is basically adding support for the event log. So this is the topic of the discussion here. Been thinking and discussing with a few folks about what would be the good options for this. There's been an ongoing discussion on the mailing list, on the local mailing list as well. Just the event log itself, the V2 comes with an ABI that basically allows user space to just push digest. And as was rightfully pointed in the review threads on the Linux local mailing list, this is kind of it's not very useful without an event log itself. So initially there was a discussion about if the event log should be taken from the kernel or left for user space to build the event log. And I think there's a general agreement that the kernel should actually maintain this RTMR event log, which is something I definitely agree with. Assuming that's
Sam, could I just interrupt? Where on the
Oh,
Linux
absolutely.
Cocoa list is this? All I see is the RFCV1, and I just checked law as well. It doesn't seem to have it either.
Actually, you added some comments on V2, James. This is
Okay, where was it? What's the subject? Got
Can you
it.
see my screen? So this is V2, and I think you were initially part of that discussion. Well, you are part of it.
Yeah, let me find the URL. So it didn't have RTMR in the title of the V0 is the problem.
That's correct. Yeah. These runtime measurement registers.
Yeah, I've got the link. Oh God, no, I can't post it. Yeah, somebody else got to it before me. Sorry.
No worries. Okay, so yeah, the discussion on the mailing list was basically we're talking about how we could maintain this RTMR event log in the kernel, and I guess to summarize the discussion and the opens for this topic to move on is we probably want to start agreeing on an input ABI. So what user space should provide to this extension ABI that the TSM configFS interface would provide, and basically what the user interface wants to extend into RTMR, and also the output ABI. So what would the kernel return when user space asks for the event log? For example, when sending that along with the attestation evidence against towards the verifier. So as I said, we had some discussions, internal discussions, also on the mailing list, in the confidential containers GitHub, because there's a related topic to that. And I guess initially I was kind of thinking that for those who are familiar with the TCG canonical event log format would make sense. What they define the canonical event log records, and it's kind of designed for taking multiple sources of measurements, which is the case here, where user space basically means any attester, any application would be able to reach that ABI and basically ask for the TSM or the kernel to extend some measurement into RTMRs. So we try to kind of make it fit into the TCG CL, but I'm not sure if this is the right option. So I put together a couple of options, and the first one is not the TCG CL. It's a more simple one, I guess, a simpler one, where basically the input would be akin to a TCG event2, which is the crypto agile TCG PCR event. It's basically the first version, but allowing for multiple hash algorithm. In our case, most of the RTMRs, well, not most, but all the architecture that support runtime measurements only support a single hash algorithm. So the idea here would be to simplify this and basically have user space submit the event and a TCG event type bind to the event. And here we also we can assume that the kernel is going to be able to generate the hash by itself of the event. So what the kernel would do with that approach is would take the event data, hash it, and basically add an entry in the event log. Basically, construct a TCG compatible event, TCG event2 compatible event with a single digest, which is the one that the current computational computing implementations supports. Usually only one, actually only one. And after this, extend the RTMRs with the generated hash. And that will be how the kernel would maintain is TCG is RTMR log, and also basically would allow for the kernel to return a TCG compatible event log as the outcome of this. So it's fairly, I would say, classical and expected. I guess this is something that's many tools out there or toolings expect when kind of reading TCG or measure boots or computational computing event logs. It's compatible with the existing toolings. Some opens with that option. Well, yeah, as I said, it's a well-known format. The kernel would have to handle, in theory, all TCG event types. If we basically say that the input is those three fields here, TCG event type, the size of the event, and the event itself. But when you look at the TCG event types, a lot of them are fairly irrelevant to a runtime measurement register use case, at least the ones that we're trying to implement.
If I can stop, if I can just say, there are only two TCG event types. One is an event where you provide the hash and the hash goes into the log, and the other is an event where the hash is the contents of the log. All the other tags are pretty much irrelevant to what you want to do. So you can let whoever wants to choose a tag do that. All you need to know is whether it falls into the event type that we provide the hash or the event type where we're supposed to calculate the hash.
Yes.
And I think if you extend the API just to take the hash anyway, you can just leave it up to user space to decide that, and the kernel doesn't need to make any decision whatsoever.
I think, yeah, this was an open for discussion, but it's also, it basically leaves user space. User space would have to basically ask TSM for which hash algorithm it supports. It's a less convenient interface, obviously, but that's another option where basically kernel is even less involved and take whatever tag comes in, TCG event tag and a hash, and just ask that to the log. Creates a record of this.
Let's be pejorative. Is there any real need for crypto agility? I mean, right at the moment, SHA-2 seems to be fine. As long as we don't do SHA-1, we could just say SHA-256 is the hash of the log, and if we'll keep the agile format, and if something screwy comes up with SHA-2 and we have to move to SHA-3, we can then do that as a kernel patch later on. That would simplify pretty much everything.
But that depends on the architecture implementation. So depending on how architectures want to implement their basically the computational computing firmware or TSM, whatever you want to call it, they may choose their own hashing algorithm, and you have to comply with this to extend the RTMR with whatever the architecture is expecting.
Is there any known architecture that doesn't do SHA-256?
Well, I'm not sure about TDX. I think is TDX doing 384?
384, yes.
Yeah, it's 384 TDX it's using.
So you have potentially different algorithms. You definitely have a single one. So we don't need to do multiple SHA-1 and SHA-2 and others, but that would need to be exposed to user space, and user space would need to get that information to generate the right hash. And well, there's no way for the kernel to actually verify that this is correct, as opposed to user space providing the data, and basically depending on the tag that user space would provide, the kernel would decide if it needs to generate the hash or not. And I think a lot of I enumerated a couple of TCG hashes types there, event types. If you look at the other ones, well, obviously the EFI ones are irrelevant to user space, extending measurements into runtime registers. There's a bunch of boot ones that firmware that also are relevant. And if you narrow down these two, the ones that are really kind of relevant to what we're trying to do, I think it's those two, maybe I don't know, a couple more with. And the event tag is quite interesting because it basically allows for precisely what we're trying to do with user space, sending potentially different applications, sending different measurements into those registers, where each and every application could decide they want to use their own format, or even internal users like IMA in the kernel. Event tag is kind of designed for this, where you use event tag, and the event data is basically a TLV, where the T is application specific or caller specific, and it's completely free for that purpose. And no action is a way for the caller to say, I want to add something into the log that is not going to be measured. Outside of those two, I don't see how the existing tag would be would make sense to application calling into that ABI.
Wait, there's no such thing as an addition to the log which isn't measured. The whole point of the log is it can't be repudiated, so everything in it has to be measured in some form. Otherwise, an event that isn't measured, you can just strip it from the log and the log will still hash to what it should.
Yeah, but it's tagged as something that is not measured, so it's informative for the verifier. This is part of the TCG spec. So if you use an event no action, it basically means I want to add something into the log. My event data is something that I want to add to the log, but it's tagged. I don't want the underlying receiver to actually measure it. So it's something for the verifier to. It's a hint, and information, and the verifier is free to trust it or not. But it's definitely not part of the. It's not trusted by default because it's not measured. But it's designed for this one. And one drawback is of this option is that basically only the digest is trusted. The event type, if you look at the format of the TCG event here, it's basically only the only thing that can trust out of all this is the event, the digest itself, because nothing else is. It reflects the event data, but the event type could be anything. The RTMR index could be modified by anything in between the attester and the verifier. None of this is measured.
Right,
which
that's
is
the standard
it's not, it's
hint event log entry, which IME uses all the time for its binary measurement.
Yeah, it's just there's been some precedent where verifier will kind of trust the event type to interpret the event data, and well, you're not supposed to do that.
Well, no, but you are. Like I said, there are two event types. One is where the hash is just recorded and the entry is just a hint, like IMA. The other is where the hash is supposed to be the hash of the entry, so you can trust all of the values in the entry.
There are other event types where you want to measure something, but that something is you basically like the vendor specific events, where you measure something that is not part of the event data itself. It's so they have.
Right, but that's type 1. It's this. I mean, the TCG goes into a huge amount of complexity, but realistically, there are only two event types. One is where you just add a hash and you give a hint to what this hash is, and the other is where the hash is the hash of the entry you made. But those are the only real two event types that you have. In practical terms, the kernel needs to understand, if it does. So can I just ask a couple of questions related to a TPM? Because obviously all of this RTMR stuff should be equally applicable to the TPMs. So what about events that have multiple entries? The usual annoying TPM use cases where we're measuring to more than one bank of PCRs. I take it RTMRs don't quite operate like this. I assume they're one bank exclusively.
I don't think, and I don't want to talk for other architectures and Intel folks, and AMD can chime in, but I don't think, if you look at the EFI spec, for example, they kind of define a mapping between RTMR and TPM PCRs for how RTMRs are supposed to be used and which range of the PCR they're supposed to cover. But there's only TDX that defines those. I don't think ARM, for example, has such mapping. With RISC-V, we are going to define
right, but I didn't ask about the
Oh.
mapping yet. I was just asking about if a recording device that has multiple banks for recording. So most TPMs come today with SHA-1 and SHA-256. And if the SHA-1 bank is active, we actually still have to measure through it. So every event that we measure actually gets two entries, one in the SHA-1 bank, one in the SHA-256 bank. I take it all that is all that still available in this ABI?
I don't think it would be available because it's irrelevant to the existing the few existing implementations don't support multiple banks.
I think yeah. So for TEEs, as far as I know, we do not support, well, at least Intel TDX does not support multiple banks. But from software architectural perspective, given the interface does not take the hash, so what I'm trying to say is that the hash algorithm that is used to hash the event itself is architecture dependent or hardware dependent. So on a TEE implementation that does not support multiple banks, then this hash will be just a single hash. If on a platform that supports like a real TPM that has multiple banks, then the kernel is supposed to know that, and then it could hash the same event data multiple times using respective hash algorithms, and then extend those digests respectively to banks.
Right, but the user space has to know this because events that are hash only have to be provided in by user space. It has to do the hash. So 2 hashes or however many banks you have, hashes have to be provided.
Are you talking about the event log format or talking about the interface? What I'm trying to say is that, well, go ahead.
You can say a standard event log has usually multiple. If the TPM has multiple banks, it has multiple entries. Usually every event has 2 entries, one for one bank, one for the other. Or if it had 3 banks, it would have 3 entries and so on. Right, but the problem is that in order to make that record for events where you only provide the hash, the thing in user space has to calculate the hash 3 times and provide it. For events where we're actually taking a hash of the event entry, the kernel could do that based on its knowledge of what banks are active. But the problem is you can't do the first one, the former, without actually knowing what hashes of what banks they're actually recording currently.
I wonder if it would be interesting to kind of move through the options, because then I think we're going to see options where we want to decide if the hash is part of the ABI or not.
Cedric, you wanted to say something?
Well, so what I'm trying to, well, I'm not sure the definition of one event log entry. As far as I understand, for the TPM2 event log format or the CEL format, the algorithm agility is implemented by providing a array of hashes, right, for a single entry. So what I'm trying to say is that the event data will stay the same, just that different digest will be calculated under different hash algorithms over the same event data, and they will be grouped into one array. So in this kernel case, the user mode application does not specify the hash algorithm because it is, like I said, hardware
architecture dependence, that provides a portability for the usable application. On the other hand, the kernel understands the underlying hardware, so it is supposed to know what hash algorithm or hash algorithms it needs to apply to the same event data or input. So it is definitely capable of calculating necessary digests and then put them together in the event log.
User space has to know the hash algorithm to calculate the hash of events that are recorded as hash only in hint.
No, but in this ABI, the hash, the digest is not part of the input. Only event data. If you can look at the picture, in user mode, the digest is not part of the input. Only the event data is the input, and kernel is responsible for calculating the hashes.
That's one of the reasons why we want to propose this ABI where we pass the events, the data to the kernel, and the kernel, because it knows the architecture, the underlying architecture support for
just wait a minute. You're setting up a problem where the entry from which the hash is calculated is large. I mean, consider the IMA one where it's taking the hash of binaries. You're saying the input under this RTMR spec for IMA would have to be the entirety of the binary, which can be, megabytes to gigabytes.
Yeah, a pointer to it, but yeah, definitely.
I don't think so. So IMA could have its own hash. So you could extend the event data by itself if that fits your application's need, or you could hash your event data and then use that hash as input. In that case, the application determines the hash algorithm you want to use. And then, of course, the kernel could hash the hash of the application data again, right? That's part of the kernel's job. Then you just consider the hash function as a compressed function, right? So in the crypto community, hash functions are also referred to as compressed functions because from informational theory perspective, they contain the same entropy.
Right. I was just asking who calculates the hash, and we seem to have arrived at the conclusion that it could be done.
So in this case, in the IMA case, right? So there are two kinds of hash algorithms. The one kind that the kernel is taking care of, that's architecture dependence, because the underlying measurement register could be from TPM, right? Which supports multiple banks and different vendors or configuration may support different algorithms. The other case would be it's a TE, like in Intel TDX is a SHA-384. If it's RISC-V, I'm not sure. Maybe Samuel can comment. Anyway, the algorithm is architecture dependent, so that part is determined by the kernel. On the other hand, the IMA or any other applications, if it thinks the event data is small enough to be hashed directly, they could just send the data right into the kernel. Or if they think the data is too large to be directly handled by the kernel, or because for whatever reason, then they could compress their data by applying a hash first and then send the hash down. In that case, the application is also able to choose whatever hash algorithm it wants to use.
But to support those kinds of things, you would need other additional event types, Cedric, where the app is saying, hey, I've sort of hashed the data, and you don't need to do that again, or you want to leave that up to the.
I think if you look at event type like the event what's it called, the event tag, it basically completely freeform and left to the application or the caller, basically the creator of the event, to define what's in the semantics of the event payload. So if the caller decides that the event data itself is a hash of a large binary blob, for example, it can decide so and tag it appropriately.
Understanding that's not how an IMA log works. The event data is the path of the binary, which is the hint, and then the hash is the hash of the binary, and that hash is directly added to the log, which means that hash has to be the same format as the log.
Are you talking about the IMA, the TLV format?
I mean, that's the way IMA does its logging.
You're talking about the IMA template, right?
Yes, but
which is
it's
different
really
from
using right, but it can be fitted into the CL format, and I think if the CL spec does include a reference to IMA.
It includes actually a couple of them, unfortunately, but yeah, it does include a reference to it. But if we'd want to have the IMA kind of fit into that picture, I guess, I mean, the event data that IMA could decide to use is well, they could have whatever they want. IMA would be an in-kernel caller, so it's could use the event data as they wish.
I'm just using IMA as an example because it exists and you all know it. If we're logging from user space, there are certain events whose data is going to be incredibly large that exist in user space but not in the kernel, and we don't really necessarily want to pass all that data over the user to kernel interface to have the kernel calculate a hash. We might just
Yeah, so in that case, the application just hash its own data and send the hash down, and it can pick its own algorithm.
Right, but the hash is supposed to go into the red field, the single hash, right? Which means it has to be the same hash as the RTMR is measuring. Same hash algorithm.
No, it doesn't have to be so. So if the application is measuring, I don't know, like to give another example, a concrete one, the large container image, for example, a multi-gig container image is going to take a hash of it and pass this hash as part of the event data to kernel space. Kernel then takes a hash of this binary blob. It doesn't even know if it's a hash or not. It just takes a hash or multiple hashes if the architecture supports multiple hashes for RTMRs. And here I'm calling into single digest because there are no architecture today that supports more than one hash algorithm for computational computing.
So you can do it that way, but the point I'm making is that the current example that does this, IMA, does not do it this way. The hash goes into the red slot for single digest, right? And it seems reasonable that for most events that are given a digest, it would also want a hint, right? Which is what IMA currently does. And so the hint goes into the event data, and the hash should go into the red box. And that means it should be the same hash as the RTMR is measuring through. I mean, there are exceptions to this. You can truncate hashes, you can extend them. We had a scheme where IMA measures the SHA-1 hash into a SHA-256 bank. So it's still not, it doesn't necessarily mean the hash has to be the same as you're measuring, but it's ideal if it is. And so you need to know what it is. And you just put it straight into the log.
So if IMA was to use a TCG event, which is TCG event compatible format, basically there's no unless IMA goes and defines a new TCG event type, which I think it's unlikely. But basically IMA would have to use a generic type like the event type, where basically it's a tag saying my event data is going to be a TLV formatted one, and the T is going to be IMA, and you can put whatever you want there. And IMA could decide that the T is my IMA hash, and the value is the hash of whatever is relevant, and T could be IMA file or IMA path or whatever IMA wants to put in there. But it would have to basically adapt the existing format to that one anyways. It's not going to be able to take the existing digest and put that in an event data because there's no IMA event type for in TCG defined, obviously. There is one in CL, but this is not the one that we're talking about.
Right, but I thought you were talking about using what I think we're sort of getting off topic. I mean, the point is, even in the TCG log, we just add an IMA tag, even though one doesn't exist. But the whole point of using CEL was to try and combine the various different log formats. They're all basically TLV, and they all have this property that either you measure the event data and that's the hash, or we give you the hash and the event data is the hint, really.
So this one, just to be very clear, this is not a CL compatible proposal. This one here, This one is really a TCG PCR event to compatible proposal. So the event here is not the TCG event. Each event on this, or each record on this log is not a CL compatible record. We have the option number 2 is basically highlighting this, describing an alternative where we would be CL compatible. But yeah, this one is really something that would be actually compatible with like an EFI event log format that you get today, which I don't think IMI is compatible with as of today.
Well, the only thing you would need to do to make IMA TCG compatible is to define events for the current IMA string listing. I mean, it's not a hard problem to solve.
You would have to add that to the TCG spec for IMA specifically.
I mean, it can theoretically be done, although I think the reason CEL exists is because the TCG doesn't want to do that.
Exactly. Yes.
And we're down to about 12.
TCG doesn't want to do that, and TCG defined this event tag thing. Oops. This event tag specific type, and if you read the spec for this specific event type, it's explicitly designed for this, for applications or non-firmware, non-EFI entities to actually generate events of, formatted structured events with their own types. And they cannot leave. They kind of hand wave you about the actual value on the actual data, how you format this and how you make sure that this is not conflicting between different colors.
Yeah, is this a detail that we can handle on the list? I feel like there's some other options we wanted to get through while we have while we have people on the call. Yeah.
Okay, we have 10 minutes left. So the second option is and this is what we just discussed about the CL TCG canonical event log, which is different from the existing TCG PCR event logs. Different in a sense where you have at least an additional field, which is the record number. You have a digest field that can. It's similar to the digest field of the TCG PCR event 2.1. But the larger difference between this one and the legacy one, I would say, is the event content. And the canonical event log, the cell, is the latest TCG format specification. And if you look at it, it's kind of trying to formalize the EV event tag, where instead of letting the caller use their own content type for the event data, TCG is trying to formalize this and define specific tags for each and every application that would call it. And it's really designed for supporting multiple testers, the BIOS, IMA, CL itself. So the specification defines a type for its own management records. And the idea of the content type here on the event content is to describe the semantics of the content, the event content itself. So the content type will tell you it's going to be an IMA specific type. The very weird thing about the specification is that the content type defines which parts of the event content gets hashed. So depending on the type, you have different parts of the event that are getting hashed. And the recommendation of the specification is that the entire content gets hashed and makes it into digest. But for legacy reason, and because they're trying to support existing applications, what they call PC client, which is the TCG PCR specification, the firmware specification, and also the IMA one, they kind of retrofitting all this into cell, where basically for example, they have two content types for IMA. The existing one, where part of the IMA events are hashed and some of them are not hashed. And then they define a new one, the IMA TLV, which is more it's following the spec basically by saying we're gonna hash the entire event and make the entire event trusted. And same as the TCG PCR or firmware spec, cell specification defines which content type are valid. So if you want to add your own content type there, you basically have to go and change the spec unless you don't care about potential conflicts between different types. If we want to use the second option, I think the ABI would be slightly different, but also the outcome would be different because it obviously would conform with the cell specification. And the ABI would basically be the event data itself without the TCG event type. And it's there's quite a few options there, but the idea and again some of it's probably a lot of it is probably to be discussed. That we would use the same content type for all records in this event log, and would have to specify this and add this content type into the specification, and the event data would be used as is, and the hash the digest that this is extended into the RTMR is basically the hash of the entire event content, the event itself plus the event type, and that constitutes a cell record, a CLR, and the event itself can be made of any native log record format. IMA could use its own, provided that they're expecting the entire content event to be hashed, which is not the case for the legacy type defined in the specification, which makes it very awkward. But then other application, other testers could define their own format and basically push that into the event. When collecting all of this and tracking the record number for each and every record in the log, that you would get a cell compatible event log out of the kernel. And you could even reconstitute the application specific native event log records from this one. So optionally, you could have other format coming out of the kernel, where instead of having cell compatible ones, you could have a native one for application willing to just look at those. This option is allows for building more native event log formats, and IMA is one of those. Computational containers could use its own one. The entire event is trusted, so the events, the event content, the content type itself, everything is trusted because the entire thing is hashed, and this is what makes the digest. The drawbacks is that we would need to add a new type into the cell specification. So I'm not sure how hard this could be and how painful this would be. I honestly have no idea, but maybe people in the call have some idea about this. And the event data kind of it becomes Linux TSM specific. So you would have to kind of prefix it with the attester type, and the verifier would get a stream of records that which content type is Linux TSM one. So the verifier itself would have to have knowledge about what the event content, event data for this content is formatted as. And this is kind of it's becoming Linux specific, and typically you would expect the event data to be somehow appended with the attester type. So CC, computational containers, or IMA if IMA wants to use its format, and so on. And if you look at the CL specification, the IMA TLV part of the specification is precisely like this. So basically, using their own content type and prefixing it with an IMA specific set of tags that are defined in the specification. So it has its drawback, and I'm talking about two IMA format defined in the cell specification. One of them maps the actual implementation, the current implementation in the kernel, and the other one is really following the cell spec itself, but is not implemented in the kernel. So it's kind of a, I don't know if it's a wish list from the cell specification maintainers to see that happening in the kernel, but it's not currently implemented in the kernel. And I think, yeah, that's all I have. I'd be curious to hear between those two options what people think is the most reasonable one. So that's obviously no decision is going to be made in this call, but at least to start pushing V3 of the patch set with something that has changed to get an agreement from the community between those two options and maybe other options if people have other views on what should be done.
Well, I'm all for simplicity, but the problem with option one, and you refer to it yourself, is TCG defines all these events for pretty much measured boot only, which means that everything else has to be shoveled into a sort of freeform record event type. And effectively, you're reinventing cell in a different format, really.
Yeah, that's right.
All of the reason I was asking about IMA is not because I really want IMA to fit into this, or it'd be nice if we had something unifying. It's because the way I see measuring events from user space, they're all going to have requirements that are pretty much similar to IMA, and therefore the way they're measured and the log entries are going to look pretty similar to IMA. So asking if it can support IMA up front is effectively asking if we can support sort of arbitrary record types. We're not really sure what they'll be.
So this one, option one, definitely can support IMA. We can, but I mean, like you said, it would be everything would be embedded in an event tag, and IMA would use its own set of types in the TLV part of the event content, event data. Sorry, hoping that the T in TLV does not conflict with others, but it's kind of the same for the cell. You have the same problem where the event part of this proposal here would have to be somehow prefixed or typed with a tester intent. IMA does this as part of the IMA TLV, which is again not implemented in the kernel, but that's, I guess, this is something we can also work on the kernel side. But any tester would have to go and basically prefix its event data with its own type. And this is, again, freeform. The other option would be for each and every tester to go and try to add its own cell official content type, which I think is, I don't think it's realistic for any application out there or any tester out there to go and work with the cell specification to get things in.
So part of the problem with the decision is it's cart before horse, really, because right at the moment we have no user space testers at all. And so we're talking about trying to add them without really knowing what their requirements are. The reason I'm extrapolating IMA is because my speculation is that's the most likely set of requirements.
Well, I don't know if that's cart before horse or chicken and the egg, but one of the things that we wanted to do was test this with a user application in a container space. So you'll see that in the V2 thread discussion. So there's been some vetting of this idea outside of IMA as a use case.
And when is that with the Avery Blanchard proposal for recording containers, or is there some other proposal?
No, it's with the CNCF COCO project.
It's with the attestation agent user space application in the confidential containers project. It basically potentially measures container images, container configuration files, and all sort of things, and would benefit from extending those measurements into the runtime registers that the architecture provides. So we would have another user. Well, actually, the first use case here.
There's also the attested containers open source project from Intel, and that would just it'd be a very similar use case. So it doesn't add a whole lot of diversity of requirements, but it does.
Well, so if I had an existing requirement we had when I was at IBM is that we would like to measure firewall configurations as well. That's where the big data thing comes from, because the usual atomic way you update a firewall is with a massive dump of records.
Yeah, so as Cedric was describing, you would basically hash this, basically compress this to a hash algorithm, and using that option, you would pass this into the kernel, and your event data would be specifically typed for your application. Which type do you choose? Which number or string or whatever format you want to use as part of event data? It's kind of it's free form, and I don't think there's a like this wouldn't be. I don't think this would be a much cleaner implementation in terms of how you would prefix this, unless you say each and every event that comes and use this ABI needs to be prefixed with for example, a domain identifier, and something that identifies explicitly your application as a string. And if you go through the Linux ABI for RTMR, you're going to have to format your event in that way. So basically, prefix it with a string that identifies your application, which is, I think, could be a URL, a UID, whatever you want to pick. And then the rest of the event would be your data, your hash data or non-hash data if it's not too large. But in both cases, you would have to kind of make sure that you can avoid conflicts between event types. That's the major problem between those two. Shared between those two, I'm saying.
Yeah, I would like to add that. So the flexibility. So because we don't know anything about future applications, that's why the key objective here is to achieve flexibility. If we think of like HTTP and how web APIs are implemented, right? There's also a content type over there, but today we can tell that most RESTful APIs, their content type will be application/JSON, right? That is the most common one. The next common one is the HTTP forms, right? Those are the so-called formats that implies certain structure or defines the storage aspects of the parameters or data that need to be transmitted over the network. But they try to stay away from the semantics of the data itself, right? JSON is a very good example. So that there are a limited number of web applications out there, but almost everyone is using JSON, right? Application/JSON as the content type. And we are trying to do the similar thing here, right? We have the Linux TSM as the content type. And then for the event data, it is actually free form. So from the kernel perspective, it doesn't have to take care of the actual event type. It only serves the purpose of storage or log transmission, right? It's more like a JSON or more like HTTP that does not care what the application does. It only responsible for transmitting the messages. And then inside that message, it is up to the application on how to use those. We definitely could provide recommendations, like the one that we discussed on the Cocoa issue. I think the number is 495. If you guys are interested, I can send out the link to that issue. It basically describes for an arbitrary free-form data, there will still be a practical way or best practice on how to avoid conflicts between applications and how to let individual applications to encode arbitrary data to eventually achieve the goal of separating the semantics of the event data from the storage of the event data. so that the kernel does not have to understand the event itself to do its job, like calculating the hash, maintain the log, and then letting other software entities to verify the log in an unambiguous way, right? And on the other hand, the semantics will be an agreement between the actual application and the verifier that will keep changing. It's basically following the same principle as people have defined JSON for transmitting data, but it doesn't get into the semantics of data. And then the application defines what goes into the JSON object or mapping, right? That's called JSON scheme. And we are trying to do the same thing.
Okay, sounds good. Like, when we respectful of people's time, like we've gone over the top of the hour. For next steps, like Samuel, do you want what do you want to see for next steps? Do you want people to feedback on the mailing list, or
yeah, on definitely on the mailing list. Maybe I can take a stab at V3. Pick one of those two options. I'm not sure if there's some strong preference on this call for one of those, and I guess it's easier to discuss implementation rather than slides for sure.
Wait,
I don't know. Dan, do you have any suggestions?
I mean, yeah. I mean, I think picking one and challenging somebody to knack it is probably where we're at, because it sounds like there's pros and cons of each, and it wasn't clear to me that I was hearing much of a application or rejection of one or the other. I like the. I mean, just from my not expert opinion, like this whole kernel doesn't need to worry about things is a useful property. But yeah, let's take it to the mailing list and see if we can get people to acrobat there.
I would venture to say I was hearing pushback on one, also maybe pushback two, but most of the pushback on one was to go in the direction of two. Did I misinterpret anybody?
Yeah, let's try two and see who shows up to say not to on the list.
That sounds good. It's it wouldn't be a lot of work to switch between those two. So we'll move into, we'll do that.
Okay.
We'll start with option 2 and see what people say on the actual mailing list with actual code.
Okay. Yeah. Well, thank you for running through this. It really helped. And really appreciate it. We will. So our next call is in 2 weeks, but that is at the kind of Australia China friendly time. We'll be back at this time slot in 4 weeks.
Sounds good.
So thanks everyone. Thanks for your attention. We'll see everyone next time.
Bye.
Bye everybody.
Bye.
Bye. Bye.